We go. Hello folks, welcome to the, I guess you could say, training video for Zombieverter VCU Firmware version 2.20A. Just having a look there before I started recording, and the last release that we did was on May the 2nd, so time of making this video today it's December 2nd. So quite a few months have passed. Now, I know that some folks would tend to think that it means that there's been nothing or not a lot going on, but there's actually been quite a lot of testing and back and forth, not just by me but by a lot of people throughout the world now that are contributing to this project. So before we get started anywhere with running through the technical details, I would like to very much thank the folks that are actively contributing. So version 2.2 is going to be released in tandem with this video, hopefully today. I've been running it for the past few weeks now in 4 vehicles that we currently have running and driving with the Zombieverter VCU. Each vehicle has a different configuration of parts, so drivetrains, chargers and various other heaters and all the other bits that we need to be able to knit together to make our EV conversions work. So currently running, driving and on the road as of today, we have our BMW E39, BMW E46 and BMW E31. Also running and driving but not road legal yet is our Mitsubishi L200 pickup truck. And that one actually has quite a different array of parts in it, and hopefully going to be on the road in the next few months. So enough about all that. Let's dive straight in to our web interface here so we can see what's different and talk you folks through the various parameters. So to get us started today, I have the E46 Touring, which is the grey goose, pulled up to the door of the barn here, hooked into the Wi-Fi, and we'll use its web interface here as our number 1 intro. What I will do then as the video progresses is I will bring each vehicle up here to the barn, hook the Wi-Fi in, and we'll be able to run through some of the different settings for you. I know there's some folks out there that kind of struggle with setting stuff up and a lot of the settings and fault finding and so on. That's one of the reasons that you don't see a lot of very frequent releases from me. It's because I like to test, and I like to make sure that we can at least give folks the confidence that it's not just thrown together, hit the compile button and oh, that's perfectly fine. It is actually tested, working, driving in day-to-day use. So let's get into it. So let's go to our web interface. This is actually known as the old web interface now. There is a more pretty green one that has the different colors and so forth on it. All of my vehicles at the minute are still running this kind of, let's call it legacy version, but it really doesn't make any difference what flavor of web interface that you may find on your VCU. So let's scroll down here to parameters. So the first thing that you'll observe is there's been a lot more, I guess, grouping of the parameters so that they're more grouped, I guess, so that it'll be easier to kind of get the high level stuff, and then you can kind of work your way down through the more nitty gritty like configurations. So if we start here under the general setup heading, this is where we choose things like what inverter we're going to use, what vehicle we're connected to, and various things like that. So let's start here. In our E46, we have the Leaf Gen 1 selection made here. Now, that's a little bit, that name is kind of bad because it's not just the Gen 1 Leaf system that setting encompasses, or I should say drivetrain, really. This is currently tested on both the Gen 1, which is the older EM, I think 62 motor, and inverter. That's what we currently have in the E46 Touring. And in the truck, as you will see later on, we have the EM57 motor and the 110 kilowatt inverter. So Leaf Gen 1 is kind of a bad name. It's kind of one of the things I do want to clean up. So this is our Leaf drivetrain. The vehicle is an E46. So let's, if we were to click on the drivetrain at the minute, that'll pull up a list of the currently supported drivetrains that the VCU can control via CAN. And if we look at our vehicle list, this is again a list of the currently supported vehicles via CAN. That's expanding and will be added to. Gear lever, the setting here, what this basically means is it's in the none setting here on the E46, and what that basically means is that we do not have a CAN-based gear lever connected to the vehicle, so it's just using the normal 12-volt signals to signal forward and reverse direction. But we do support currently these gear levers, and at the time of making this video I am working on the MG gear shifter center console thingy. We then get into the transmission choice that affects some of the CAN messaging on various vehicles. In our case, that's a manual. The charging interface is, do we have some kind of a system between the charging port and the actual onboard charger? And in the case of the E46 Touring, we do. We have the BMW i3 Lim, which supports CCS fast charging. We have a list here then of the supported charger interfaces, which is currently the Lim, we have CHAdeMO, we have CPC, and of course the new FOCI system. Charger modes lets us select what kind of a charger that we have in the vehicle. In this case, with Mitsubishi Outlander CAN controlled charger, and we have a list then of the other chargers that can be supported. Now this is a new one, BMS mode, that's currently set to off. And if we look at the next setting down, shunt type is set to ISA shunt, because we have an ISA IVT shunt in the E46 Touring to provide battery voltages, currents, powers, balance, all that kind of thing. Now, I know there's been some folks that have not wanted to use that kind of a shunt in their builds because they're kind of tricky to get and they can be expensive also. So what we have is a list of different currently supported shunts. So if we go down here and we look at our shunt type, you'll see that we have four options. We have the ISA shunt, the BMW S-Box, and also the Volkswagen Group equivalents to the BMW S-Box. But we've also got the choice for none. Now, if we happen to set that to none, and then we went up to the one ahead of it, parameter 6, which is our BMS mode, we bring up that menu. Oh look, now we have a choice of BMSs that we can support. We have the Simp BMS, we have some TI daisy chain, we have the Leaf BMS, and we have the Renault Kangoo 33. I believe that's a 30 kilowatt hour battery pack. So what would happen if we were to select one of those BMS types and have our shunt type set to none? Well, what will then occur, as you will see with the truck, is that it will basically use the data from the battery management system and the inverter to provide the necessary voltage and current and all of that stuff that VCU needs. So as of this release now, it's possible to use the VCU in cooperation with those BMS types for the purposes of gathering your high voltage system information that the VCU needs. So that these two are intrinsically linked. As you will see for the E46, as I say, we have BMS off and we have shunt type set to ISA. In the truck, we bring that up. I'll go through this again, but you will see a very different kind of a setup here. The rest of them are pretty straightforward here, folks. We just choose which of the two main high-speed CAN buses that our various components are connected to. So I'm not going to run through those. I'm going to scroll down here though, however, to parameter number 18, MOT active. Now this parameter only pertains to the Toyota drivetrains that we currently support. So Lexus GS 450H, Lexus GS 300 and Toyota Prius Gen 3. And the MOT active setting here lets us select how we use the two MG motor generators in the gearboxes. So obviously the first is that we use MG1 and MG2. Next there we can use MG1, we can use MG2. But the last choice here is been one that I've been most impressed with. It's blending MG2 and 1, and I've been driving that in the E39 now for the last few weeks, and I have to say it's very nice driving experience. Just yesterday I drove about 120 kilometers with that setting in there, and it was very nice. So if you're running a Toyota drivetrain, I would strongly advise giving that a try in this new software version. Quite simple terms, what it does is for low speed driving, only MG2 is used, and once we exceed a certain throttle demand, MG2 kicks in to provide the old VTEC just kicked in yo kind of a situation. So let's see, under the throttle heading then, pretty much this stuff is pretty much standard stuff. Now there is one new setting here, number 34, which is reverse regen. And that is, do we want to have regen functioning when we're reversing the vehicle? So pretty straightforward. So that's just plain Jane on-off decision that you can make. So let's see, run down to our other ones. Okay, so we have a Trot Max reverse. So that's number 43, and it means what it pretty much says on the tin. What is the maximum throttle setting that you would like to have in reverse. So some people don't like the idea of going full speed in reverse, so you can set what percentage of basically torque command or throttle command, however you want to look at it, will be available in reverse gear. Let's see, everything else is pretty standard. Nothing's changed here really. We do have the ability, certain chargers want to have the AC voltage programmed into them. Charge efficiency, you can set there for deciding how efficient your charging system is. So for example, if we take in 10 kilowatt hours measured from a charging point, how much of that 10 kilowatt hours actually ends up in our battery as usable energy. Now number 67, config FOCI, and that is a on-off choice. And what that will do is, if you are using the new FOCI system that was developed by Uwe and Johannes and crew, which I will be installing in the truck and in the Red Arrow myself. Don't have those currently set up. But the config FOCI, what it will do is if you have FOCI and VCU connected via a CAN, the VCU will then configure the settings within FOCI to use with the Zombieverter VCU. So kind of a one-click setup, I guess, sort of a thing. We've got our DC-DC settings, we've got our battery management settings, they're all straightforward. Heater settings, we've got our RTC module. So, under general purpose I/O, there's a few new things going on here and I do want to stress the importance of. So, parameter 89, pump PWM. So on our VCU, we have a hardware pin that I originally designed as for driving solely the Lexus GS450H electric oil pump, speed control via PWM. But what we can also use that for now, if we so wish, we hit the menu, we have a tachometer output option on there now that will basically allow us to drive a old school analog style tachometer that needs pulses. And if we had that set there, and if we were to scroll right down to parameter 111, we have tacho PPR, which we can set anything from 2 to 100 pulses per revolution. So for example, in the Panzer, which has a pulse-driven tachometer on the dash, I have that set up, I think it's the 4 pulses per revolution, because it'll be expecting a V8. And in the truck, we've also got a pulse-driven tachometer that uses 2 pulses per revolution. So that's a nice additional feature. We have the function for what's called CP spoof available as a output for any of our 3 PWMs. And CP spoof is in fact used in the E46 at the minute, because we have the Mitsubishi Outlander charger, but also the BMW i3 limb in between the charger and the actual charging port. So the limb gets the control pilot and the plug present signals from the charging station, converts those into CAN bus, which lets us do things like CCS fast charging. But then the VCU will convert that data back into the actual PWM that certain onboard chargers, such as the Mitsubishi Outlander charger, need to see in order to function. So that's what CP spoof means. Now, You will see here parameters 100 to 102, PB 1, 2 and 3 in function. And we can set those to certain inputs. They are input pins, and we can assign inputs to them. Now, it's vitally important, if you don't listen to me through any other part of this video, you listen to me for the next few minutes on the function of the PB pins. The PB pins were never designed to be general purpose inputs. They were designed for the gear feedback positions in the Lexus GS 450h gearbox. Just keep in mind that has a high and a low gear in there, and they have feedback switches in there to tell the VCU which gear that the gearbox it has currently engaged, or indeed is in the process of changing gears. So they're not designed to have voltage or current driven into them. They're simply a pull low signal, so they can be either left floating or they can be connected to ground. So if you have a signal that you want to supply on one of those PB pins, it must only be a open circuit signal or a pull to ground, so vehicle ground, chassis ground, 0 volts, battery minus, whatever you want to call it. You must not attempt to drive any voltage or current into those pins, okay? So no 12 volt connections, 5 volts or anything else going in there. If you do that, you're going to irreparably damage the VCU. So please pay attention to that one. Otherwise, like me, you will be doing it wrong. And who wants to be like me? Nobody. Rest of them are pretty straightforward. The VCU also has the ability now to be a kind of a charge interface itself, if you so wish. The plug present signal can be connected to one of the general purpose analog input pins. If we look at the list on those, you'll see proximity pilot as being one option, and also a brake vacuum sensor. So the VCU can, control a brake vacuum pump also, if you so wish to do that. I don't do that. In my vehicles, the brake vacuum pump is triggered by the simplest possible system, which is the brake light switch. But obviously other folks will want to do things like that. We have the ability to set the resistance on the 2 digital pots on the VCU now, so anything from 0 to 255 will translate into the resistance range that the pots supply. And also we can set a fan temperature here, because the VCU can control your fans now, like me. You can, I can control my fans. That's handy. So, ISA init is the ability to configure our ISA shunt. That's been there for a good while now. And our timers can be configured for various outputs, and because we can assign these now for providing PWM signals and things like that, that certain things, let's say for example Nissan Leaf water pump can be PWM controlled, so if you wish you can set that up there under the PWM system to give you a certain pump speed and things like that. That's a little bit experimental at them. Well, it's not that it's experimental, it does work, but it's not like straightforward as like, set your pump speed to 20% or something like that. You have to do a little bit of maths on it still. CP PWM lets you set the spoof value for your PWM that you would have here in the event that you do not have a charger interface going on there. So you can set a manual value. As you will see here, it's set to 0 because I have the limb in there and it provides the necessary value in there. So the spot values is pretty straightforward. There's a few new ones in here. Most are straightforward. Our temperatures and digital inputs and outputs and so on. I think we do, yeah, if we come down here now, we've some more feedback data from our onboard chargers. So when that data is available, it will be filled in here in these parameters. And also we have, again, yeah, we've got things from our brake vacuum pump control, our PP value, and various heater data as well. Also, we have vehicle lock status, because certain vehicles like the E90 class will let you know when the vehicle is locked or unlocked via CAN. So, that is, folks, pretty much a quick rundown, as quick as I can make it for you anyway, through the parameters on the Grey Goose, at least for software version 2.2. So before we wrap up this particular segment, there's one important thing. When you upgrade to version 2.2, because there are certain changes made to the timer hardware on the STM32 microcontroller, you will need to power cycle the VCU before commencing using it or driving your vehicle or whatever. Some folks get a little bit confused as to what that means. So what it simply means is remove the permanent 12-volt supply to the VCU for a period of 5 or 6 seconds, reapply power, and you should be good to go. So you will find a link in the video description to the GitHub page with the release on there. So by the time that this video airs, you will be seeing the release up there on GitHub. So folks, what I'm actually going to do is I'm going to stop this video here, and I'll do a separate, completely separate video where I walk through the vehicles and show you the different configurations in them, because I suspect this one is probably getting a bit long, and I would like folks to pay a bit of attention to it, because apart from anything, it'll help to clear up any confusion or questions that some people may have. So folks, I'll cut it there. Don't forget, you're doing it wrong. Link in the description to our VCU software page. I will also be uploading onto the GitHub repository the parameters of all of the vehicles that are currently running version 2.2, both for the VCU for all 4, and also for the Tesla large drive unit that is in the Panzer. Because I've heard that some people are having trouble interfacing, or I should say using the open inverter interface. So hopefully that information there will help clear up any questions on that topic. So that's it, folks. As always, don't forget to give this video a good thumbs down. However, if you are using or planning to use or thinking about using a Zombieverter VCU, do recommend this to your friends and do crack open a cold beer and watch it, because like I said, I'm trying my best to describe things in as much detail as I can without getting over into a 3-hour special. So that's it, and until next time, or the video which I'll be making in a few minutes of running through the various cars. Happy VCU firmware flashing.